Alright, hey, I'm going to just randomly choose someone, maybe like, Peyton. Alright, Peyton, tell me what you did here. And were you able to make this work? So you looked at, let me catch up to you. Okay, so here is, if you did a 45-degree angle, okay? What you said this was square root of 2 over 2 and square root of 2 over 2, okay? Awesome. So x is cosine, right? Y is sine. So Peyton went and plugged in a specific value and said, well, if I do square root of 2 over 2 squared, that's going to be the sine plus square root of 2 over 2 squared. Is that equal to 1 squared? And when you squared that, you got this to be, what did that become? 2/4 plus 2/4, is that equal to 1? And sure enough, it is. Awesome. So, good job, Peyton. Huzzah! Nice cat. Okay, so great. That was a good example that it does work. Now, what I want to kind of go over is where did this even come from? How did someone figure it out? Okay, so I'm going to draw another picture here. I'm going to just add, so find a blank space on it. Let's talk, I'm going to go through and try a little bit different here. Instead of plugging in a point, I'm going to talk more kind of general here. Alright, as Payne pointed out, why is it called the unit circle, guys? Why is it called the unit circle? Thank you, Mikkel. Adam, driving me crazy here. No, I'm just kidding. Okay, so the radius is 1 unit. There's why it's a unit circle, alright? Okay, so if I were to look at this and draw a right triangle here, okay? The Pythagorean theorem tells us that if A and B are the legs and C is a hypotenuse, then what, guys? What's the Pythagorean theorem? A squared plus B squared is equal to C squared, right? Now, we're on the unit circle here, so let's change this a little bit. Instead of A, that's going in the x direction, B is going in the y direction, and C is the radius in this circle. So this is actually x squared plus y squared is equal to r squared. But we've been doing a lot of work here, and we were able to figure out that we can actually replace x with what? What trig ratio? X is cosine, good job, so this is cosine squared of theta. And what did we replace y with? We said sine. And going to add them on this, it's the unit circle, which means the radius is what? 1 unit. Yes? 1 unit. What is 1 squared? So this is, we're going to just change the order a little bit, but either way is fine because the order of addition doesn't matter. Sine squared plus cosine squared is equal to 1. That's where this comes from, okay? And as Peyton pointed out, you could plug in values and it works. You could go through every one of those on the unit circle and it's a true statement. Now, we're going to use this. This is going to become your new best friend for solving trig identities because it's going to help us out on these more complicated ones, okay? So, this is kind of just doing the same thing that we did. It just kind of explains what we just did. So if you want to read that on your own time, great. We're going to go ahead and just jump to this, okay? Now, there's other forms of this, and I guess I'll show you that to you real quick as well. because those are going to show up as well. So let's first off, let's make a list over here. I'm going to replace this one. So what I'm going to write here is I'm going to say sine squared of theta plus cosine squared of theta is equal to 1. Now, that might show up on a trig identity. You might see sine squared plus cosine squared. And what can you replace it with? 1. That makes it nice. Two alternate forms of this, if I just subtract the cosine squared over, is I might see sine squared is equal to 1 minus cosine squared of theta. How if I just subtract that over, right? So that means if you see 1 minus cosine squared, what can you replace it with? Sine squared, right? Yeah? That's an alternate form we're going to use. Similarly, if we subtract over sine squared, we're going to get cosine squared is 1 minus sine squared. So this is our Pythagorean identity and two alternate forms it could show up as. You should have those written down somewhere to kind of help you remember. You don't want to lose track of your tools. Okay, so now let me hurry and show you some alternate forms here too. What this is asking you to do on your notes here is it wants you to get, this is another identity here. It's called, or if we just read it, it's 1 plus tangent squared of theta is secant squared of theta. And it wants you to verify that. Well, what we're going to do here, if I have cosine squared here, and I turn it into 1, how would I do that? What would I have to divide cosine squared by in order to make it 1? What do you divide something by to turn it into 1? Itself, right? So what would we be dividing by here? But if I divide one thing by cosine squared, what do I have to divide everything else by? So what I'm going to do is I'm going to divide everything by cosine squared. What is cosine squared divided by cosine squared? 1. What is sine squared over cosine squared? That's tangent, but since they're all squared, it's tangent squared of theta. And then 1 over cosine squared of theta is going to be secant squared of theta. This is going to be an alternate form, another Pythagorean identity that we're going to use, but it's not using sine and cosine, it's using tangent and secant. So 1 plus tangent squared of theta is equal to secant squared of theta. Now, I could also rewrite this a couple of different ways. Let's just subtract over that tangent. And I'm going to say, well, if I see 1, it's equal to secant squared of theta minus tangent squared of theta. So if I'm ever going through an identity and I see secant squared of theta minus tangent squared of theta, what can we replace it with? 1. Also, if I just subtract that 1 over, I get tangent squared is equal to secant squared of theta minus 1. Now basically what's going on here is I'm giving you some tools to help you solve these. These are a little more complicated. We won't see them a whole lot, but I want you to have them just in case. Okay, we're going to do the same thing here, but now instead of dividing by cosine squared, what I want you to do is to divide by sine squared of theta. So let's take these guys right here. We're going to divide by sine squared of theta. Because last time we divided by cosine, right? Yeah. What is cosine divided by sine? Cotangent. What is sine divided by sine? And what's 1 over sine squared? Secant squared of theta. So this is another trig identity, but it just stems off of the one that we already had right here. So sine squared plus cosine squared is 1. So I'm going to write our last one here. and the order you write it doesn't matter, but we'll write it 1 plus cotangent squared of theta is equal to cosecant squared of theta. Do you need to memorize these? No. But you do need to have them written down somewhere. Okay, the other way I could write this is I could write it as 1 is equal to cosecant squared of theta minus cotangent squared of theta. Or we could say cotangent squared of theta is equal to cosecant squared of theta minus 1. Okay, so what we're going to do now is we're going to try to solve some of these harder trig identities. We're trying to verify them, which means we're going to make the left side look like the right side. Now, what's maybe fun about this, but also kind of frustrating to some people, is there isn't a right way to do this. There's more than one way you can prove an identity. Sometimes that's frustrating to people where they're just like, I like one way, but the others are like, oh, that's cool, there's more than one way. So we're going to use these tools and try to come up with some ideas. But first, let's just kind of reinforce this. I just threw a lot of information at you. So to help you absorb it, I actually printed off kind of a summary cheat sheet, okay? So I'm going to tell you guys, it should only take you 5 minutes to fill this out. And then this is going to be kind of your study guide for helping you do your homework, okay? So I want you to buddy up. You're going to take 5 minutes here. Fill out this trig sheet cheat sheet.